Right, people, the last lesson, I just forgot about these last sketches here, and I'll just talk you through some of them. Um, I just spoke about figure 3.8b, and this one here is a special one, okay? Special in terms of structures, okay? Because when we work on structures, this is the situation, the scenario where we always want to be in, okay? There's a pivot point, okay? Well, let's assume it's a mother and a son, or a guy and a girl. Um, the girl is sitting here, she's 0.8 meters away, and she weighs 300 newtons. The guy sits 1.6 meters away, and he weighs 150 newtons. Okay, so about point D, okay, this will be plus 300 times 0.8, and about point D, this will be minus 150 times 1.6. Okay, and when we do the moments, don't just listen to me and say, I'm doing it in my head. No, don't do it in your head. Write it down and work it out and verify that what I'm saying is in fact the case. Okay, I can make mistakes, so you need to check it out. And when you check it out yourself, you learn also. Okay, so you'll see there that that force multiplied by 0.8 minus that one, because it's anti-clockwise, 150 times 1.6 is equal to 0. What does it mean? Well, that's the answer there, 0. What does it mean? It means that this lever here, the seesaw, is going nowhere. It's staying there. Okay, so although this force is acting on it, the whole system there is in equilibrium. Okay, very important, equilibrium. Okay, the room where you're sitting in, there's walls. I'm assuming you're inside a room. There's walls. There's a roof. The wind's blowing. The roof is weighing down there, but everything is staying on one place. Why? Because the whole system is in equilibrium. So even though forces are acting, forces want to blow over, forces want to, the weight of the materials make it want to cause to drop down, but because the reactions are all going the same way and equal opposite directions, in effect, the whole system is in equilibrium. Okay, so therefore the sum of the moments about D is equal to naught. Why? Because that whole system there is in equilibrium. Very important. Okay, and when a structure is in equilibrium, we use that fact to find the reactions of other parts of structures. Okay, from this point onwards. Right, that's page 3 on the document. I'm going on. There's an exercise there. Let's just calculate the moments of the forces shown in the following diagrams. Also state whether they are positive, which is clockwise, negative, anti-clockwise. Right, there's the first one there. Force times distance. It is not 84 times 0.25. Why not? Because that force there is not that angle there is not 90 degrees. It's 55 degrees. So you either need to resolve this into components or work out or draw the line from the point of rotation at right angles to there and work at little d. Okay, there's the answers, there's the direction. Sorry there, that should be 0. Okay, well, sorry, minus, that should be minus. But anyway, that arrow that tells us it's going anti-clockwise. There's the next one, same thing over there. Okay, it's also 84 newtons, it's also 250. But there's another angle there. Notice there, even though the force is the same as that one, and even though the lever arm in millimeter is the same as its other, the moments are different sizes, and they go opposite directions because of which way the forces are wanting to turn the lever. Okay, so work it out, get it correct, check your answers. There's the next one. The answer here says a 0. Why is it 0? Because the force is acting along that line there through the point of rotation, and because the distance is 0, anything times 0 is equal to 0. There we go. Okay, right, and then that one there, you can do it if you want to. You need to first convert this into components, have a go at that. If you don't do it, that's not too serious, but that's, yeah, we'll try that one there. Okay, convert these to components and see if you get that moment there. There's a moment there, and it's positive. And this one here, you don't need to do, but you can do it if you want to. There's the answers there. If you don't want to do it, that's fine. That's like just to tease your brain a bit more. Okay, so people, that's all I want to say about that one there. And this frame I'm going to do in another lesson. Okay, it's in another folder altogether under frames. Okay, so people there, that's all the bits on principle of moments and the exercises and the lessons that go with it. Do them all, check the answers, and you'll be ready to go on to the next lessons for frames. Okay, I'll see you in the next lesson.